The answers have quite an interesting way of doing this question, though I'm still convinced that the best way to do this question is to simply color them in. If the chessboard got really, really big and we had to do it, then yes, we would need an alternative approach. We'd have to really think about it, but you'd have to start making very, actually quite complicated arguments for the patterns that are going to occur. So I'm just going to avoid it here and simply go with coloring it in. Black, white, red, and so on. So I'm just going to now go around the whole thing, circling when they're the same. This is interesting. There's this clear pattern of the diagonals being used, and that's what the answers sort of talk about. And we can justify it because we can say, for example, to get from here to here, I've added 9 on because I've added 8 to get to the one below and another one. So of course it is going to be the same. So we can make that justification. It's just understanding that then that one is going to become white and start a new pattern that is less obvious. And one here as well. So definitely interesting to generalize this to larger numbers of squares and how we can investigate it. But for our purposes here, I think it's absolutely fine to do this. Let's find the little pockets. We've got 3 here in the top right. We've got the leading diagonal, which has 8 down it, and 7 for the white diagonal, which has one less square. And then there's actually 5 here. So 7 plus 8 is 15. Add the 5 to give 20. 23 squares have the same colored counter as the color of the square. There's 64 in total. So 23 over 64.